Okay, for this lesson, we are going to learn more about solving our OR compound inequalities. Here's our two goals. Our first goal is I can solve an OR compound inequality. And our second goal is I can graph an OR compound inequality. Okay, so those are goals. Let's take a look at some vocabulary words first. A union or an OR statement is a compound inequality that is true if at least one of the inequalities is true. This represents the combination of both graphs. A real-world analogy would be to get a student discount, you must be a student or under the age of 12. Do you have to be both? No, you just have to be one. And then we need to know a lot about our boundary points. These are our critical values. This is the value where an inequality begins or ends. And we're going to be using open circles if we're using a less than or a greater than symbol. Or we're going to be using closed circles if you have a less than or equal to, or a greater than or equal to. So let's look at a few steps that you'll need to follow. First, you're going to solve each inequality separately, as if it was written as its own problem. And then second, you're going to keep the word or between your answers. Then we'll graph each separate inequality on the same line. So let's take a look at this first example. So we're just focusing on this one right here for now. Sorry about that, my computer glitched. Okay, so we're just going to focus on that right now, nothing else. So we want to solve this and get x by itself. So we have an x minus 3. So the first thing we're going to do is, get a new pen, we're going to add 3 to this side and then 3 to this side. Because remember, whatever you do to one side must be done to the other side. So these cancel out and I get x is less than 2. All right, so that side of the compound inequality has been solved because x is isolated and by itself. Let's go to this other one over here and solve this one. So we have x plus 2 is greater than or equal to 5. So we have to subtract 2 from both sides in order to get x isolated or by itself. So 5 minus 2 is 3. So we have x is less than 2. And then we're going to bring down the word or x is greater than or equal to 3. So we have solved our compound inequality. And now we are going to graph this inequality. So this 2 right here, this is what one of my boundary points is that we talked about earlier. And this 3 is also a boundary point. Let's take these boundary points and we're going to put them on our graph. So I'm just going to write down a few numbers on my graph. Let's just start with like -2, -1, 0, 1, 2, 3, 4. Okay, so our first boundary point is at 2. So I'm going to put a circle at 2, and we need to decide whether it's going to be open or closed. Well, notice that there's not or equal to on this one. So that means it's going to be an open circle. Okay, and the x, or it's pointing to the left, so I would fill in everything to the left. I'm going to shade to the left. Okay, my second boundary point is a 3, so I'm going to circle at 3. And notice there is an or equal to sign with it. So that means we have to fill in the circle. And which direction are we going to shade? It's pointing to the right, so we are going to shade to the right. And there is our graphed solution. Basically what this means is you have to choose any x that would be smaller than 2, but not including 2. Or any number bigger than 3, but you could include 3. So you would pick any one of those numbers, smaller than 3, or smaller than 2, or bigger than 3, and that would be an answer or a solution to this inequality. All right, let's do another one. So we got x over 4 is less than or equal to -2, or x is less than 2, or x minus 2 is greater than or equal to 1. Okay, so let's just focus on the first inequality. So we're just going to focus on this one right here. X divided by 4 is less than or equal to -2. So x divided by 4, the inverse operation is multiply. So we're going to multiply the left side by 4. And we're going to multiply the right side by 4. Those cancel out. And I get x is less than or equal to -8. Because -2 times 4 is -8. Okay. Now, let's focus on the right side. We're going to add 2 to both sides. And we get x is greater than or equal to 1. So, don't forget, we have the word or in between them. And there we have solved our compound inequality. Now, let's go ahead and graph. So just like last time, we need our boundary points. We have a boundary point at -8 and one at 1. So I'm going to go ahead and write down from -8 all the way to 1. So let's just focus on this first one. Put a circle at -8. Is it going to be open or closed? Should be closed. Awesome, because we have an or equal to sign right there. And we're shading to the left because it's pointing to the left. Okay, look at the 1. Put a circle there. Open or closed. Once again, it is closed because we have an or equal to sign. And it's pointing to the right. And there is the graph of this compound inequality. So to find a solution, you need to have any number smaller than -8 or any number bigger than 1. And in this case, you could include -8 and 1 in your solutions. All right, now we have some two-step inequalities. Let's work on these. So let's just work on the left side, on the left one first, this first inequality. So two-step inequality, first thing we're going to do, we have to add 5 to both sides. And we get 3x is less than or equal to -14 plus 5 would give me a -9. Okay, let's go ahead and divide both sides by 3 now. That way we get our x by itself. We get x is less than or equal to -3 for our first boundary point. All right, come over to the right. Let's go ahead and solve this one. -3 to both sides. We get 2x is greater than 8. Divide both sides by 2. And we get x is greater than 4 for our second boundary point. Okay, on your assignment, these will already be labeled down here. But for now, we're just going to go ahead and label these. So let's go with -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, etc. You can put a -4 here. Okay, so the first boundary point is -3. So put a circle. Open or closed? Should be closed. Shaded to the left. Your second boundary point is at 4. So circle at 4. It is open because there is no or equal to sign here. And we're going to shade to the right. And there is my solution. Oh, don't forget to put or between here. There is my solution and its graph. Okay. One last thing we need to remember about our, when we're dealing with inequalities. When you multiply or divide by a negative, remember the inequality sign has to flip. Okay, we've explained that in an earlier video. But what happens when you multiply or divide by a negative? It changes the sign of the number. Since the sign of the number gets switched, we also have to switch the inequality sign. That's how it works. So, last example here. Let's go ahead and solve these two-step equations. So -2 from both sides. And I get -4x is greater than 8. And then I would divide by -4. So I get an x and a -2. But since the 8 switched to a negative, since I divided by a negative, this greater than sign flips to a less than sign. We have to do that. If we don't, we will get it incorrect. Okay, so there's my first boundary point. And our second one, Let's go ahead and add 8 to both sides. And we get 5x is greater than 15. We're going to divide both sides by 5. And did I divide that one by a negative? I did not, so the sign stays the same. And 15 divided by 5 is 3. Okay, so we have our boundary points. Let's go ahead and plot them down. So -3, -2, -1, 0, 1, 2, 3, etc. So my first boundary point is at -2. It is open because we don't have the or equals to sign, so we fill to the left. And then open at 3, fill to the right. Okay, when you do this on your assignment, it's going to be slightly different. So I'm going to include a little video just after this one so you can see an example of how you're actually going to answer these on the computer with your assignment. But that is the math explanation behind it. So let's review our goals. I can solve an OR compound inequality, which is just solving two individuals' single inequalities. And then we can graph the OR compound inequalities by using our boundary points, figuring out if the circle is open or closed, and then shading in the correct direction. So watch this short video after this to see how you do it on the assignment. And if you have any questions whatsoever, feel free to reach out to me.